So this is example 4 on the 6.1 worksheet. We've got one function is cubic. Then you've got another one. Okay, so here we would want to, again, to find the points of intersection, you'd set these things equal to each other and solve. So this is going to lead us to a cubic equation, though, so let's see if it's easily solvable. Minus 2x to the third. We've got, let's see, minus 8x squared. We've got plus 6x. And fortunately, those 3's are going to cancel, so that makes this nice. Right, so it looks like we can factor a 2x out of there, right? And if we do that, we're going to be left with x squared minus 4x plus 6. Did we do that right? Hold on a second. Let me make sure I'm doing it right.
Plus 3, right?
Well, the 3's would have canceled, I think. Oh, plus 3. You're right. I'm sorry. Yes, you're right. Plus 3. Okay, perfect. So then we can factor that, and we can divide by 2 if we want to. So we get x, and we get x minus 3 and x minus 1. Right, so that gives us x equals 0, x equals 3, and x equals 1. So those are 3 points of intersection. So clearly we're going to have to do this situation where we've got this thing crossing in 2 different places. All right, now the graph. Again, the graphs aren't entirely that important, but they're probably helpful. So let's see, we've got a quadratic with 2 x-intercepts at 1 and 3. So let's see, 1, 3, and it's opening up. Probably something like this. And then we've got a cubic that has negative leading coefficients, so that means it's going to kind of do, I should probably continue that up there because we're going to have an intersection at 0. All right, so if I plug in 0 to the other one, I get 3, so I guess that one's going to be here. And then if I plug in 1 to that other one, in fact, I don't know, I think I'm just going to have to graph these on my calculator because I can't think about what they're going to look like. Give me a moment, I'm going to put these on my calculator. So my drawing's not that great, but you can see there's a region right there, right? And then there's another one right there. Everybody see the 2 different regions there? You can graph it on your calculator if you want to get a better look at it. Anyway, so what are we going to do to set this up? The total area will be integral from 0 to 1. That's the first 2 intersection points. And if you want to put this where the top function is first, according to my drawing, it seems that the quadratic function is first there. So you get x squared, or is the bigger function there, minus the cubic function. And then simplify that. Well, actually, let's just write the whole thing. So plus, then we're going to have to do another integral, the integral from 1 to 3, where now the cubic function is the bigger function and the quadratic is the smaller one. Or again, it really doesn't matter that, if you don't want to worry about the bigger function here, you're perfectly welcome to just put the cubic one first in both cases, and then whichever answer becomes negative, just make it positive at the end. Because one of them will be negative if you do that, if you don't decide that one of them is the bigger function. Okay, so there's the 2 integrals that we have to figure out. Obviously not, they're kind of messy there, but let's simplify these. So the first one we're going to get, we do have some like terms, right? Let's just put this in descending order of power. So it looks like we're going to have 2x to the third. Let's see this quadratic term, the second power terms, x squared minus 9x squared, so it's minus 8x squared. And then the first power term is minus 4 plus 10, so that's plus 6x. And then minus, or plus 3 minus 3, so those 3's are going to go away, so we get that. So it simplifies to something a little nicer. And then antiderivative, so raise that to the fourth power, you get 1/2 x to the fourth minus 8/3 x cubed, and then plus 3x squared. Plugging these in from 0 to 1 is nice. If I just plug in 1, I just get 1/2 minus 8/3 plus 3. What is that? 5/6, I guess. And then we got to do the other one as well. So for that other one, we're going to get. So here, if you notice, when we the only difference on the integrand itself is that those the one function is now first, whereas it was second last time. So what's going to happen when we simplify these is everything is just going to end up being negative of what it was before. So we're going to get this. We simplify that. And then we'll plug in or find the antiderivative, same exact antiderivative, so except that the signs are going to be different. So we'll have minus 1/2 x to the fourth plus 8/3 third, and then minus, plus 6x. This time we're going to plug in 1 and 3. Did I screw up the antiderivative on that one? Oh, I sure did. I even had it right on the first one there. Sorry about that. Let me fix that. So that should have been, yeah, I had that right on the first part, didn't I? 3x squared. Great. So that's going to change a couple of things, isn't it? Yeah, so that's going to change this 18 to a, let's see, minus, yes, right. If I plug in 3 there, I get 9 to 27, right? So that should be a minus 27, is that correct? And then for this, if I plug in 1 there, that should be minus 3. (16/3). Does that sound better? And 16/3 plus 5/6, 37/6. Sorry about that.